Hello, today we'll talk about loss function. And suppose we have data set consisting of many object target pairs. Each object has corresponding transfer. And for today, for this task, we will practice evaluation of our error for our predictions, at least for one object. And this is how it looks like, this formula. Our this function AFX is our prediction and y is target value. We square the whole thing to get a loss function. Uh, this for how this formula looks mathematically. So basically, loss function is an error of single object, simply called loss, or squared error, commonly used as a squared error. We will take one example. Suppose we have company and three features: competitors, capital, and card price. And we want to make prediction of the price, how much this company cost in the 1 year. And suppose the 1 year passed, we got our true value, and also we did our predictions, and now we can see how far we went. Suppose the data is like this. Suppose this is the data: competitors, uh, equity, price 1 year ago, and we try to predict price. Suppose 1 year passed, we got these targets 45 and 36, and we also did our predictions with 46 and 33. So we subtract our prediction from target value or an opposite direction, doesn't matter. Anyway, we will square this result and we will get 1 and 9 for the second company. So we see that prediction for company B was much farther than for company A. Again, we'll look. Object x1 got an error 1 and x2 got an error 9. And what's here? Yeah, beautifully. We had three features: true value, prediction value, and we calculated our loss function for both of these objects. Now that we waited a year and seen actual stock prices, we can finally calculate our model was. Yeah, we actually already did that. It's kind of, I don't know why, it's a double of what we just told. Yes. One more question that we might have: why squared error? Again, the quadratic deviation squared error is just one example of a loss function. There are many different ways how we can calculate the loss, and this might be depending on the problem. For now, let's stick with this one. It's intuitive and widely used. Key idea that squaring penalizes larger errors more heavily. For example, an error of 3 becomes 9, while an error of 1 stays 1. If you remember how quadratic equation looks like a parabola, quadratic function looks like a parabola, then bigger x we take, and much bigger square bigger we get y. So the idea of squared error is heavily penalized if we go farther from our target values. So now we learn how to evaluate the error of our algorithm on a single object. But what we really want is to understand whether the model is good or bad overall, and to compare different models against each other, not object by object, but as a whole. And for that, we need something bigger that is called quality functional or a risk functional, and that's what we'll explore next. Thank you.